Good. Y approaches 2. Very good. And then on the right side, as x approaches infinity, and you can say positive infinity, that's from the right. What's the y approaching?
Negative infinity.
Good. Negative infinity. Are y'all okay with number 2?
Yes.
All right. So let's look at 3. I made an uh-oh on Friday, and I was kicking myself in the foot afterwards. So when I taught this to y'all, I showed it to you like this, right? Yes.
Yes.
Okay.
Yes, ma'am.
So what I forgot to mention, because Friday was just a crazy day, if it says 1 plus, think about your exponential functions. 1 plus, is that growth or decay?
Growth.
So if you see 1 plus out front, that is going to be growth no matter what your base is, okay? I know we talked about how the base is bigger than 1, it would be growth. Base is less than 1, it would be decay. But if it says 1 plus, the whole thing is going to be growing. Are we okay with that?
Mm-hmm.
So this one is growth, which means it's increasing the entire time. So from negative infinity to infinity, it'll increase. Decreasing, there isn't any. Now let's just review our logistic functions from Friday, because does everybody agree this is logistic? Hello? Y'all agree this is logistic?
Yep.
Yes, ma'am.
Okay. Why is it logistic? There's 2 things. Tell me one.
One, there's like a constant over the exponential equation.
Good. There's a carrying capacity. Very good. Who was that so I can give you your extra credit? Is that Kendall?
Kendall.
I thought. So there's a carrying capacity, and then the other reason the exponent is x and it's in the denominator. Okay? So those are the 2 things that make it logistic. So if you guys remember from Friday, logistic functions have 2 asymptotes. The first one is always y equals 0, because you can't have negative populations, you can't have negative money, that kind of thing. And then what's the second asymptote always?
Carrying capacity.
Good. And what's our carrying capacity here?
6.
6.
Good. So those are your 2 asymptotes. So we know this function is in between 0 and 6. All right, I am not worried about the concavity. I put that up there to challenge some of you, so we're not going to go over it right now. It's not on the test. If you want to learn about it or have a question about it, pop in office hours or stay after this, okay? So the next thing I'm going to go find is my y-intercept. So who can remind me from Friday how we find a y-intercept algebraically? You could put this in Desmos and find it that way, but I want to know, how would you find a y-intercept algebraically?
Set x equal to 0.
Good. So put 0 in for x. So this is going to be 6 over 1 plus 4 times 0.6 to the 0 power. So what is anything raised to 0?
1.
So this is just 6 over 1 plus 4 times 1. 4 times 1 is 4. 1 plus 4 is
5.
5. So our y-intercept is just 6/5. Okay. So to graph this, I'm going to go up 6/5. So that's a little past 1. That's 1 1/5. And then it's going to curve to make an exponential, but then it levels out at that carrying capacity at the top. So that's what your graph would look like, kind of like an S. All right, so what's my domain?
Negative infinity to infinity.
Good. And the range is in between what two numbers?
0 and 6.
Very good. I want to say your name, but I can't. I have to work on that. It's crazy. All right, end behavior. So if we look at the left side of the graph, as x approaches negative infinity, remember that's the left side. What is y approaching over here?
0.
Good. Ooh, that's an ugly 0. And then as x approaches positive infinity from the right, what is it approaching?
6.
Good. So are y'all okay with the logistic function? Y'all okay with number 3?
Yes.
Okay. Your test does have a logarithmic, a exponential, and a logistic function. You're either going to have to graph it or you're going to have to look at a graph that I give you and tell me the features it asks for. Okay? All right, so for A, convert each equation to its alternate form. So if you look at A, this is a logarithmic equation, which means I want you to convert it to exponential. All right? So to convert a log to exponential, we take the base, raise it to the solution, and it will equal the argument. This is your loggy froggy if it asks you to convert. Y'all hang on one second. Hey, I'm doing a live Zoom right now. Sorry. All right. Sorry, that was twice in a row that somebody at school tried to call me. So the base is what of a logarithmic equation if there's nothing there? What's my base?
10.
Good. So this is 10 to the 1/3 x should equal x plus 5 squared. And I didn't ask you to solve. I just said convert. So you could have left it just like this. All right, so then check C. Same thing. It's a log equation, but what kind of log equation is this one?
Natural log.
Natural log. So same thing that we're going to take the base, raise it to the solution, and it'll equal the argument. So what's my base of this equation, of the natural log?
E.
Good. So this is e to the 3 minus 6x equals 7.5. And you could have left it just like that. It didn't say anything about solving. It just wants you to convert. Does that help with number 4, people who wanted to see those?
Yes, ma'am.
All right, so let's check while we're on this. Let's check 4B, and then I'll scroll back up to A. Or not A, Lord Jesus, number 1. Y'all, it is a Monday. I'm struggling today. So for B, remember if it's natural log, you don't need to put base E. You can just put natural log of 24 equals 2x. Are y'all good there?
Yeah.
Go up to 1 and let you check number 1. So I did on this one, I showed you the parent function and I graphed this one by hand. You can absolutely do that, but you also do not have to. You can use Desmos on your test, okay? Because y'all can use Desmos on your exam. Any questions about number 1?
Will your increasing and increasing always be the domain?
Yeah, so this is very good question. This is where is the graph increasing or where is it decreasing? When is it increasing? When is it decreasing? So those are talking about the x's. So the increasing, decreasing intervals will always be the domain. Good question. Extra credit.
Is that the still the test review paper?
Yeah, yep.
Okay.
It's white. I made like a big copy for myself and blew up each problem so y'all would be able to see it better.
Okay, thank you.
Am I good to move number 1?
I can't see the end behavior.
Can't see that. There you go. How about now?
Mm-hmm.
So I think a lot of you for this one, I saw you putting positive infinity. Make sure for a log equation, it's a vertical asymptote. So x should approach that asymptote from one of the directions, okay? Just depends what side the graph is on. All right, is anybody still checking or copying, or am I good to flip to the back?
You're good.
Okay. And I will put a picture of that key up later so you don't have to go back through and watch the video. But I'm gonna wait and make sure everybody has turned theirs in first. All right, so let's look at this side first. Which ones do you need me to do besides number 6? I'm definitely doing number 6.
Number 10.
10,
Can you do number 7 for me?
4,
Number 5.
number 5, beautiful. Hey, Colin, you snuck in on me.
Didn't you let me in?
No, I have the waiting room off.
Oh, okay.
Number 19.
Just the left side, but I will do 19 on the right side.
Okay.
You're good. Just the left side. So 5 through 14. Are these the only?
do 14?
Yep. I was just about to ask if anyone needed 14. All right, 5, 6, 7, 10, and 14. Are those good? And then we'll check the other ones. All right, I'm gonna go with those. If you need a different one while I start working, just let me know. So for number 5, I'm gonna zoom this in really far. What kind of equation is this that they want us to solve?
An exponential equation.
Good. So an exponential equation. So remember, for an exponential equation, you are trying to do what? There's 2 things. What's the first thing we should always try with exponential? Get the same
Basis.
There we go. Get the bases the same. And if you can't do that, then I'm going to take the what of both sides.
Log.
There we go. Y'all remember your goal steps. What does G stand for? Get the same bases. And then you can take, if you can't do that, then you take the log of both sides. Remember your steps for solving, okay? All right, so for this one, is there any way we are going to be able to make 3 and 1 have the same base?
No.
No.
It
I mean, you
is.
can divide by 2.
Oh, okay, so good. If it was just 3 to the 5x equals 1, you could make those have the same base. You could write 1 as 3 to the 0, right? But what Kevin just said is there's a 2 out front that's multiplying. So the very first thing you should do is get rid of anything that is not the base and the exponent. So that 2 is not the base, it's not the exponent. So Kevin, you said divide it, right?
Yeah.
Okay. So from here, I have 3 to the 5x equals 1/2. So now let's look at our bases. Can you write 3 and 1/2 to have the same base? It's not a trick question.
No.
No, good. So 3 and 1/2 cannot be written to have the same base. So what do I do if I can't get the bases the same?
Log.
Log of both sides. Good. So log of 3 to the 5x equals log of 1/2.
Mhm.
What do I do now? Come on, y'all. What can you do with this 5x?
Take
Bring it
it
to the front.
outside.
Good. If it's a logarithmic equation, it shouldn't have exponents because remember, logs and exponential are inverses. So we have to bring the exponent down. So this is 5x log of 3 equals log of a half. And then how do you get the x by itself?
Divide the log.
Divide log of 3 and divide the
5.
good. So you'll divide 5 log of 3 over to the other side. All right, so if you do log of 1/2 divided by 5 log of 3, I got x is approximately negative 0.13.
Yeah.
And if you plug that back in for x and check it in a calculator, it does work. So just make sure on your test you're checking your solutions you get because sometimes they don't work. Some of them don't work.
What I did instead of taking the log of both sides, I did loggy froggy.
Very good. Good. No, that's good. So I'll show you on my whiteboard. Your other option, once you get here, I'm going to zoom out just a little bit. Once you get the 3 to the 5x equals a half. Oh my God, that's blurry. Y'all got to tell me when it looks crazy. There we go. All right, so your other option, once you get here, you can take the log of both sides, or if there's just one exponent, you can do loggy froggy. So we could have also done log base 3 of a half equals that argument. And so from here, Kevin, what'd you do?
I solved the log. I put log 3 base 3 of 1/2 in a calculator.
And then
Divided by 5.
good, divide by 5. Very good. So you could also type this in the calculator and you should get the same thing. I got to give y'all nicknames or numbers or something. I don't understand how this is going to work without me saying y'all's names, but that's okay. Questions on number 5? Anybody, or we're okay?
Okay.
All right, so number 7, let me get it zoomed in for y'all. Take a look at number 7. Is this exponential or logarithmic?
Exponential.
Exponential, so I'm going to try to get what the same, and then if I can't do that, I'll take the log. So what are we going to try to get the same?
Bases.
Bases.
Good, bases. And you should have seen these two numbers, 49 and 2401, 2,401. And you should have gotten excited because what can we rewrite them both to have a base of?
7.
Good. So 1 over 49 is the same as 1 over 7 squared, right? So 1 over 7 squared is the same as 7 to the negative second. And then I'm going to bring down the exponent that was there before. And then 2,401 can be written as 7 to the what?
4.
Good. 7 to the 4th power. And then I'm going to bring down the exponent that was there before. Some of you took the log of both sides. You can do that, but that was a lot more work. So always check to see if you can get your bases the same. Okay?
Yeah, because I did that, and it was a lot of work. I don't know why I did that. I said, 'cause I took the laws of both sides, and it was a lot of work, so I don't know why I did that.
Because you forgot you can get the bases the same. I did the same thing, Kelly, on y'all's homework last week on one of the problems, and I was so mad at myself.
Yes.
So once the bases are the same, what can we do with the exponents?
Bring them down.
Set them equal.
Set them equal, good, because if the bases are the same, that means the exponents would have to be the same for this to be a true statement. So I'm going to go ahead and distribute, if that's okay with y'all. So this will be on this side, 2x minus 30 equals, over here you'll have 8x minus 8. And then we just solve. So this one shouldn't be too bad. There are a couple on your test where you can get the same base. So I'm going to subtract 2x over. That'll give me 6x minus 8 equals 30. And then I'll add the 8. So 38 equals 6x. And then, nope, did I do that? I didn't do that right. This was a negative 30. So this would be negative 22. And y'all let me do that. Drake, you're supposed to hold me accountable for this stuff.
My fault.
It's okay. And then divide by 6. I love how he said my fault. So you should get x equals, if you reduced it, it would be negative 11 over 3, right?
And we could leave it as negative 22 over 6, right?
Not if it says simplest form. If it says simplest form or simplify, you need to simplify. Good question.
But for this one,
It'll say simplify.
okay.
Delta math, if you get a fractional answer, it always says simplify. If for some reason you forget to simplify and you put this, I'll give you half credit. But it'll say simplify.
It's cool.
Yeah.
I did 49 to the negative 1. I got 49 on both sides, but I still got negative 11 over 3.
Good. So the other thing you could have done, remember with these, there's usually more than one way to get the bases the same. So Ross is saying 49 squared gives you 2,401. Right, Ross?
Yes, ma'am.
So he wrote this as 49 to the negative first, and he wrote this side as 49 squared. So if you get the bases the same and set the exponents equal, he had different numbers right here. Well, when you solve it, you'll get the same thing. Very good. Extra credit. Good, good.
I have a question.
Uh-huh.
If we left it as negative 22 over 6, would that count?
I'd give you half credit.
Okay.
Mathematics just asked. Yep. I wouldn't give you full credit. Delta math would count it wrong if it says simplify. But I go back in and check the ones that y'all type stuff in for.
Okay, thank you.
You're welcome. All right, we're gonna do 6. I'm just going a little out of order. I want to look at 10 because 6 is pretty challenging. So let's look at 10. What kind of equation do we have in number 10?
A logarithmic.
Logarithmic. Look at your vocabulary. Good. It's a log equation. What do you guys notice about these two logs?
Bases are different.
The bases are different. Can we do anything if the bases are different?
Change the base.
Okay, good. So if the bases are different, you cannot do anything to solve. So what Maddox is saying is we need to change the base, okay? Remember, for log equations, your goal is to condense it to one log and then do what to solve?
Loggy froggy.
Good. Yep. So we need to change the bases so we can get them the same. Condense to one log, and then we should be able to do loggy froggy to solve. Okay. Which base do we want to keep? Which one did I teach y'all is always easier to keep?
The smaller base.
The smaller one. So we need to rewrite log base 16 of x to be log base 4. Okay. So remember your change of base formula. We can do log base 4 of the argument over log base 4 of the original base, which was 16. That's your formula that we wrote down actually it was 2 Fridays ago. And then we're gonna leave the log base 4 of x because it already has a base of 4 and it should equal 9. So if you do this correctly, it should always work out really nice because what is log base 4 of 16? 4 to the what gives me 16?
The
2.
second.
Good. So this is just 2 down here. So this is just log base 4 of x over 2. So now to condense this to solve it, I need to move this 2. I need to get rid of this denominator. So instead of dividing by 2, what can I do?
Multiply the whole equation.
Very good. Multiply the whole thing by 2. Is everybody okay with that?
Yeah.
Okay. So what happens if you have 2 in the denominator and you're multiplying by 2 in the numerator for this first part? What's going to happen?
They cancel.
They cancel. So this is just log base 4 of x plus, then right here, distributed in, this would just be 2 log base 4 of x. And then 2 times 9 is 18. All right, so from here, I showed y'all in class, there's actually 2 ways to solve it once you get here. So I'm gonna do the first one up here. If I have 1 log base 4 of x, because do we agree this is an understood 1 as the coefficient?
Yeah.
Okay, if I have 1 log base 4 of x plus 2 log base 4 of x, what does that equal? What log base 4 of x?
3 log base 4 of x.
Good. I was about to make fun of y'all. 1 plus 2 is 3. Come on, come on. So 3 log base 4 of x equals 18.
Can't you also put the 2 in the exponent
Yeah.
area?
That's the second way I'm going to show you. Yep.
Okay.
But this way actually ends up being easier. You get smaller numbers, and it's one less step. Then you could divide the 3, because the 3 is not a part of the log. And so we get log base 4 of x equals 6. And once you have 1 log and it's by itself, what can I do to solve this?
Loggy froggy.
Good. So 4 to the 6th will equal x. And when you type 4 to the 6th in your calculator, I gotta look. It's 4,096. That's the first way you could finish solving this one, okay?
Would it be okay if I just kept it as 4/6?
I think so. I think in Delta Math you can type in 4/6 and it'll be the same. To be sure, Kevin, or to be safe, I would just make sure that I simplified it. Y'all can use a calculator. But the second way to solve this one, what Maddox just asked me is, can't we move the 2 to the exponent since we're dealing with logs? Yes, so then you would have log base 4 of x plus log base 4 of x squared equals 18. And then we need to condense to 1 log. So if you're adding, how do you condense the arguments? What operation do we do?
Multiplication.
Good. So this would be log base 4 of x cubed, if I multiply those, right? Equals 18. And then same thing, you would do loggy froggy. So if you do 4 to the 18th power equals x cubed, then you would just have to take the cubed root of both sides. So in your calculator, I'm throwing stuff, you would do the cubed root of 4 to the 18th. So you can do it this way, it's just an extra step from the one up there, okay? But you do get 4,096 either way. Are y'all good with 10?
For number 8, isn't it like similar to number 10?
8 is similar, yep. So once you condense number 8, it's just like this down here. You'll do loggy froggy, and then you end up, I think it ends up being a quadratic, yeah, because you would have 2x plus 4 squared. I'll show y'all mine and you can check, unless somebody needs me to do it.
Thank you.
Uh-huh. All right, am I good to move on to 6? Are y'all good with 10?
Mm-hmm.
All right, I'm gonna zoom this way out because we're about to use this entire whiteboard probably. All right, so number 6, we have 70 equals 1,120 times 89 hundredths to the x plus 3 power plus 32. Okay, this looked very challenging for some of you. It does take more steps, but this is just like a lot of the ones we get in the word problems. So what's the very first term I should move to try to isolate the base and the exponent?
32.
Good, so did y'all subtract 32 first?
Yeah.
And so that would give us 38. on the other side? And so
I
what,
wrote 48.
huh?
I wrote 48.
Oh, it's 38. So then how can we get this base and exponent isolated? What do I need to move next?
Divide by 1120.
Good. Divide by 1,120. And let's see. That does reduce. Are y'all fine if I reduce this fraction so the numbers are smaller?
Yes, ma'am.
I'm just going to type in 38 divided by 1120 and hit math, enter, enter to change it to a fraction. And it doesn't reduce that much, but that's okay. This is better. So that's 19 over 560 equals 0.89 to the x plus 3. All right, this is an exponential equation. So you should always check first, can I make these bases the same? Can I?
I think I logged both sides.
Yeah, you cannot make these bases the same because this would be 89 over 100. They have nothing in common. You cannot make the bases the same. So you do take the log of both sides. Now, my loggy froggy people, I would not do loggy froggy for this one because you would get log base of 0.89. And when we learned about logs, you learned that the base has to be a whole number, okay? So you need to take the log of both sides. So log of 19 over 560 equals the log of 0.89 to the x plus 3.
If you did loggy froggy, would you multiply the whole equation by 100 to get the 0.89 89?
No, so you can't change the base of an exponential equation. Like if the base is 0.89, you can't make that 89 by multiplying everything else by 100.
Okay.
Okay, good question though. All right, so now I have logs, but then I have an exponent. Am I allowed to have an exponent when it's a log equation?
No,
No, so what do we do with it, Kel?
put it to the front.
Good. So this is gonna be log of 19 over 560 equals, and x plus 3 is more than one term. So are y'all good if I put it in parentheses? What can I do next? What should I do next?
Divide by
both.
3 log 0.89.
Okay, yeah, you actually could do that. Yep, that's fine. That's actually easier. First thing you could do, you could distribute log of 0.89, but I actually like their way better. So divide log of 0.89 over to the other side. Good job, boys. That's easier. Extra credit. And then once you type this in the calculator, what's the only other thing you'll have to do if we're left with x plus 3?
Subtract 3.
Subtract 3 from this. Very good. Look at y'all. So this minus 3 will equal x. I'm going to double check y'all just to make sure. I did it a longer way. I like their way better though, but let's make sure we get the same thing. Log of 19 over 560 divided by log of 0.89 minus 3. Yep. So it's approximately 26.03 when you type that in a calculator or Desmos.
So what if we did do Loggy Froggy and once we got it by ourselves, we just typed the whole thing into Desmos?
That is not going to work in calculus. You cannot have a log base that is a decimal. Remember when we took our logarithmic equation notes and our logarithmic function notes, and we always wrote that b had to be greater than 0, and I also told y'all it was a whole number?
Mm-hmm.
So, I mean, algebraically, technically, you will get this, but if you're taking the log base of a decimal when you get to college math, that's you'll learn it why it won't work, okay?
Okay.
All right. So we're okay with 6. You did have a couple like this on old homeworks.
What was your way of doing it?
Oh my goodness. I distributed because I didn't see what you saw. So I did like a ding dong. So Kelly, this is me doing more work too, and I'm mad about it now too. So I distributed log of 0.89 in. And so I got x log of 0.89 plus 3 log of 0.89. So then I had to subtract 3 log of 0.89 and then divide by log of 0.89. A bunch of extra crap. But it still worked. I got 26.03. There's always more than one way to solve these. Y'all okay with 6?
Yes, ma'am.
All right. I'm going to do 14, and then I will put up my work for y'all to check for the other ones on that left-hand side. All right, so 14, a business purchased for $650,000 in 1997 is sold in 2000 for $850,000. What is the annual rate? Okay, I think this is why some of us were confused on this one. Did it say compounded continuously?
No.
Did it say compounded annually, semi-annually, quarterly, biannually, monthly? Did it say any of those?
No.
No, but what kind of rate does it say?
Once a year.
Annual rate. So that means compounded annually, okay? So you should have used A equals P 1 plus R over N raised to the NT. If it says annual rate of return, that means they're compounding it annually each year. All right. So the business was purchased for $650,000. That's the initial. We sold it for $850,000. My rate, we don't know. So are y'all fine if I put R?
Yes.
Okay.
Yes.
Then N is the number of times it's compounded in a year. So if it's annual, we're only compounding once a year. Raised to the 1. And then what's my time for this problem?
3.
Good. How'd you get 3?
1997 is 0 and count up.
Yep. So 98, 99, 2000, 3 years. So all we have to do for this one is solve for R. So do you guys agree? Same thing. We got to get the base and the exponent isolated. So did you guys divide 650,000 first?
Yeah.
Okay. And when you do that, I'm not going to copy the zeros. It reduces to 17 over 13. And then what's R divided by 1?
R.
Yep. So this is just 1 plus R to the 3rd. So this one actually isn't too bad. What's the opposite of cubing something?
Finding the cubed root.
Cubed root. Good. So I'm going to take the cubed root of both sides. Those will cancel. So I've got the cubed root of 17 over 13 equals 1 plus R. And then how do I get R by itself?
Subtract 1.
Subtract 1. Good. Maddox getting all the extra credit. The rest of you better start speaking up because some of y'all need them points. So if you type in your calculator cubed root of 17 over 13 minus 1, you should get for the rate 0.0935 blah, blah, blah. In Delta Math, and on a previous homework, it said round to the nearest 10th of a percent. So what that means is I want the percentage and then I want 1 decimal place behind it if it says 10th of a percent. So this as a percentage, do y'all agree would be 9.35?
Yes.
But I only want 1 decimal place, so that would be 9.35.
So on Desmos, on the test, will it specify like what it
Delta
wants
Math?
us?
Yeah,
I mean, yeah.
you're good. Yep, Delta Math will say if the rounding matters, it'll tell you how to round. Okay,
Okay.
very good.
And when I write my equations, I always take out as many zeros as I can that the A and P have in common.
Yep, that's
Okay.
fine. So you had 85 equals 65.
Yeah, or I think I wrote 8,500K.
So you're going to end up dividing and reducing anyways for ones like this. So that's fine. Yep. All right, I'm going to put up, which ones did we not do? 8, 9, and then 11 through 13. So I'll let y'all check 8 and 9 first. Look at all my beautiful color-coded work for y'all. I did my best. Maddox, believe it or not, this was in the car. It's pretty good, right? They always make fun of me because I do my keys in the car. That's good handwriting for being in a car.
You can hardly tell.
So check 9 and 8. I feel like we should be okay with those though. Those look very similar to ones that you had on old homeworks. And you can also see 11. So check your number 11.
For number 11, does it? Oh, never mind. I just realized that you have the dollar sign in there.
Okay. You don't have to put the dollar sign in Delta Math. Stuff like that, just remember I go in and check whatever you typed in. So I will make sure you get credit if it's an equivalent answer. Has everybody checked 8 and 9? Can I slide?
Yes, ma'am.
Yes.
So again, for like ones like number 12, just make sure you pay attention to what Delta Math says to round to, because I think one of the ones on the test says to the nearest year. And then I think another one says like 2 decimal places or something like that. So just make sure you pay attention to what the questions ask. The Delta Math format will be very similar to your quiz, but the questions are very similar to your study guide. Okay?
Miss Poole.
Yeah.
For number 13, I got the correct answer, but I didn't explain why. Would that be half credit?
So the one similar to this on the test has like a big text box, and it says like something like after 5 years, which deal is better, explain and justify. So you'll have to type in an answer for that one and explain. So if you don't explain and it says explain, I'll take points off. Yeah. Does that help?
Yes, ma'am.
They always put one of these on y'all's exam because y'all's exam is not all multiple choice. Unless they change it this year, who knows? I did speak to someone Friday and math exams are still on the table.
How many questions are there?
On your test or on the final exam?
Final exam.
They're usually 33 to 35. Just depends on the year. All right. Last side. So we know we need 19. What else? Does anybody need 18, 17, 16, 15, or 20?
16.
Can you do 17?
Yes, 17. Kayla, did you say 15 or 16?
16.
16.
And
Or was that
20.
Billy? I can't tell. Prodnia, you said 17. Right?
Yes, ma'am.
And Miss Poole, can you do 20?
Yep. All right, so can y'all still hear me? They got the Segway going in the hallway and it's loud. Y'all can hear me?
I can't
Mhm.
even hear the
Yes.
segue.
Okay. Okay, good. Well, good. It's bothering me, but that's okay. All right. So 16, a sample of an element had an initial mass of 180 in the year 2000, and it decays exponentially. So this is your growth or decay. So it says it's decaying, which means we'll do 1 minus the rate, right?
Mhm.
A measurement in the year 2004 found that the sample's mass had decayed to 140. What would be the expected mass in 2020? So the first thing we have to do, if you read this first part, so not even the next question, but it says it starts at 180, it's decaying, and then in 2004 we ended up with that much. They didn't tell us a rate. So the first thing you have to do is solve for the rate, okay? So I'm gonna do y equals whatever our initial is, we're talking about decay, and then it's raised to time. So this is one of the very first equations we did on that day where we did growth and decay. So my initial was 180. I ended up with 140 after, if we started in 2000 and now it's 2004, how many years has it been?
4.
Good. So this is just like number 14 that we just did, where you had to find me the rate first. So we should have divided by 180. So 14 over 18, and if I reduce that, that would be 7/9 equals 1 minus r to the 4th. And then what's the opposite of raising something to the 4th power? How do I undo that?
Finding the 4th root.
4th root, good. So we'll have the 4th root of 7/9 equals, and once I take the 4th root over here, that's just 1 minus r. Then I need to move the 1 over by subtracting, right? So that's the 4th root of 7/9 minus 1 equals negative r. And then how do you make r positive?
Divide by -1.
Divide by -1, good. So we're gonna divide this by -1, and that'll equal our rate. Does anyone have questions on that part? Because from what I saw on y'all's homework, that's where you guys were messing up.
Could we just write negative? Oh, sorry, go ahead.
No, you go ahead.
Could you write -4 to the 7/9 plus 1?
Yes, so you could just change the signs to get rid of the negative, or you could literally just type this in the calculator and know that your sign is going to change because that's a negative r, and just change the sign of your answer.
Yeah, thank you.
So when you do this, you get approximately 0.06, but let me ask y'all a question. What happens if I put a rounded rate into my next equation?
It's going to throw everything off.
Throws everything off. So I told you not to round your rates. What do you need to do with this rate?
Set it to X.
Save it as X.
Good. Store it as a good. Or if you're using Desmos, copy the whole decimal, okay? Because now the problem says, what would be the expected mass in the year 2020 to the nearest whole number? So in 2020, we start out with 180 still, that's still my initial. We know our rate is now X because I just stored it, right? So 1 minus X. And then if it's 2020, how many years has it been?
20.
Good, 20, because we started in 2000. So if you type this in and hit the X button, since you stored your rate as X, I got 51 milligrams if you round it to the nearest whole number like it says.
I did it to where like it decayed continuously. So since it was decay, but I got the same answer.
Use APERT.
Yeah, APERT.
That's fine. APERT is the same as growth and decay.
Okay.
They're fine. Compounding is not the same. So make sure if it's talking about money and it's talking about compounding, that you pay attention to which compounded formula you should use. But growth and decay actually come from APERT, so that's fine.
Miss Pool, for mine, I didn't like realize it was like 22%. So I took like 73% of the 78% of each and just multiplied it by each until 2020. And I got the same answer. Could I still do that?
Yeah. So can you, let me see. I'm trying to put together what you said you just did. So from 180 down to 140, you said is 70, how much percent?
It was like, oh, it's like 78%, 77% almost.
Yep. So like around 78%. So he said he just continued every 4 years from 2000 to 2004 was 4 years, decreasing it by about 78%. And he still got 51. That would also work. KJ, just make sure you show me your work. Okay. Very good. Are we good with 16? Yes, no, yes.
Yeah, I'm okay.
Okay. So for 17, I'm going to do this on a whiteboard. I feel like these keep throwing y'all off because you're worried about not knowing the formula, or is that why? Or is it just because the formula is long? Or we don't know? Does that mean we don't know? If y'all are very quiet.
Yep.
Okay. At least you were honest. That's a minus.
You're
You
welcome.
have to know the formula for this one. Remember me telling you that. The exam will give you this. And Delta Math gives you this formula as well. Now, we talked on Friday. If you watched the live Zoom where I answered homework questions, I did not record it because some of you hadn't done your Delta Math yet. They use a negative K in Delta Math. It does not matter because when you solve for K, you'll end up dividing the negative out. So it doesn't matter. Use whatever they give you. Or if you don't like this, you can just make it this. You'll get the same thing because you end up dividing out the negative at the end anyways, okay? So don't let that throw you off if that's what threw you off. But the initial environment temperature is, let's see, it says it's placed in a room that's 80 degrees. So this would be 80 plus. The initial temperature of the skillet is 400. And then the first part of the problem does not tell us what the rate is. That is an issue. That means you have to solve for the rate. So this is just like the one above it, okay? But it does say after 5 minutes, so the time is 5, the temperature is 350 degrees. So the first thing you had to do was solve for the rate. So are you guys okay if I go ahead and solve this for R?
Yeah, yeah, go ahead.
Okay. I wanted to make sure y'all were okay with how I plugged it in. So if you're looking at the problem and they don't give you a rate, a lot of you tried to skip to this step. You don't know how long it's going to be until the temperature is 200 degrees because you don't know what the decay rate is. You don't know what the cooling rate is. So you have to find the rate first, okay? All right, so I subtract 80. That'll give me 270 equals, that's 320 e to the 5r. Then divide by 320, so that's going to be 27 over 32 equals e to the 5r. And since this says e, we could do loggy froggy where we take the log of, or I just told you the answer. You could take the log of both sides. It would just need to be a natural log because there's an e, right? Or you could do loggy froggy. Which one do y'all want me to do? Which one do we want to see?
Natural log.
Of both sides or loggy froggy?
Of both sides.
Okay. So if you take the natural log of both sides, what happens when I have the natural log of e?
It cancels.
It cancels out.
Okay, good. Why? Tell me why, because you are right.
Because the natural base is e.
Remember your identity property when we did your properties of logs? If the argument and the base are the same, that would just be e to the first gives us e, right? So this just becomes a 1. And then you bring the exponent down. So this is natural log of 27 over 32 equals 5r. And then you'll just divide by 5 to get your rate. Are we okay with that part, with solving for R? Because this is technically the third time we've done this on the test review. Y'all okay with solving for R?
Yes.
Okay, let me know if something doesn't make sense or if you need to see it a different way. So this rate ends up being negative 0.034, but can you round the rate right here?
No.
So what are we supposed to do with this?
Store it as X
Store it as X.
or whatever variable.
Well, in the calculator, you have to store it as X. I guess you could do alpha and choose a different number, but I don't use the alpha button. I use this link button right here that has the X above it.
Sometimes
If we don't like have the scientific calculator, what I do is I just plug in, like for this one, I would plug into the rate. I just plug in natural log of 27 over 32 divided by 5 so that it's still exact.
Yep. It's perfect. You can do that actually in your phone. Or you can use Desmos and you can copy and paste the entire rate. All of those ways work. Good job, Grace. All right, so now that you know your rate is X, now, Pradnya, I can answer the question. So the question says, I thought it was about to freeze. I was going to be so upset. The question says, how long will it be until the temperature is 200 degrees? So we're going to use that same equation, but now we're just going to find out the time. How long do I need to let that skillet cool so that it reaches 200 degrees? Okay? So it's going to reach 200. I'm using my same formula I did on my whiteboard. We started out at 80. The initial temperature of the skillet was 400 and it's cooling. So the temperature is going down to 80 degrees because that's the temperature of the room. We know our rate is X now and we don't know the time. So that's what we're going to solve for. So you're going to solve this the exact same way. So the first thing I need to do is what? Come on, children. What do we do first? We're solving.
Subtract 80.
There we go. Subtract the 80. So this would be 120 equals 320 e to the xt. Remember, your x is just your rate that you stored. Okay. I just don't feel like writing natural log of whatever it was over 5. So then we'll divide the 320. So that would be 12 over 32, which is 3/8. Is that right? Somebody check me. 3/8 equals e to the xt. Then you can either natural log both sides, or since it's an e, we could do loggy froggy for this one. Does anybody want to see that?
Loggy froggy.
Okay, I'll show you loggy froggy for this one. So you would do log base e, which means it's a natural log, of the solution, 3/8, equals the exponent. And so to find time, we'll just end up dividing by our rate here. Remember, x is not a variable, it's my rate that I just found. And when you do that and you solve for t and you plug all that in a calculator or into Desmos or wherever, you should get for the time, it'll take 28.87 minutes for that skillet to cool to 200 degrees.
Is it possible to solve this without a or an r?
You would have to do kind of what KJ was talking about, where you could make a table and try to find the pattern for how much it's cooling, like find the rate of change. But I mean, you'd have to do that 29 times. And even then you wouldn't get the exact 28.87 minutes. You'd be able to see from the table it's between 28 and 29. So to get the accurate exact answer, no. Now, once you got, I'm thinking, no, yeah, there's not another way to do this besides making a table. And I'm not going to show you that way because it won't give you the exact answer.
So like in real life, with if you had a pizza that you're cooking and you took it out and you want to know when you could eat it,
When it
You-
wouldn't burn your mouth, yeah, you could use this formula.
but would you need like a thermometer to get the rate from the beginning, like after 5 minutes?
Yeah.
Okay.
Look at you asking real world problems. I love it. All right, are we okay with 17 now? Pradnia, did that help?
Yes, ma'am.
Okay, there is one of those up there tomorrow, so make sure you're okay with that. If you're not, you can come to office hours later. 19 and 20 are really the exact same. And the reason I'm saying that is because you can put, I guess they're not the same. All right, I'll do them both. I'm just late for our meeting, but that's okay. I didn't expect this to take over an hour. All right, so 19, I'm going to go kind of fast. If you still need help on it later because I went too fast, just come to office hours. But they give you this weird formula. What does this look like?
APERT.
It does look like APERT. So remember, I told you guys for any exponential law formulas, like it says exponential growth, Kevin, this is what you were saying. You just used APERT. Exponential growth comes from APERT. So you can use APERT here. Okay. So what they're asking, what is the growth constant K? If you look at their formula, that means we need to solve first for R again. So this is the fourth one where we're having to solve for R. All right, so the initial amount of bacteria is 150. 6 hours later, he has 600. So that would be 600 equals 150 E. We don't know R, but we know it's been 6 hours. Are you guys okay if I don't solve this for R and I just tell you what rate I got? Because we just did one like this up at the top.
Yes.
Okay, so the rate I got was 0.23. And it says leave it in 2 decimal places. So I left it as 0.23. Just make sure tomorrow you pay attention to how Delta Math tells you to round, okay? All right, so this next one, when will the biologists have a population of 5,000 bacterium? It doesn't say to solve algebraically. So this is why on your test tomorrow, I left Desmos open on these. So I'm going to stop sharing so I can pull up Desmos for y'all. And I don't know that I have it open. Oh, I don't. I have my online shopping open though. Desmos. Let me move y'all down here. All right, so it says, when will the biologists have a population of 5,000 bacterium? So what you can do, since we just found the rate, of course you won't round it, but you can type in y equals the initials 150 E, and then the exact rate was, let's see, natural log of 4 over 6. The exact rate was 0.23104,90602, and then X. So that's my equation solved for rate that they gave me. Again, you could solve this algebraically by putting 5,000 in for Y and solving for the time. But what I did was I graphed Y equals 5,000 and I saw where they crossed. Because to me, that's quicker. I think most of you probably think that's quicker. You have to zoom out really far. And then I'll zoom in up here so we can see where they cross. So when will the biologist have 5,000 bacterium? They intersect right here. So how long does it take him to get 5,000?